Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Hope you are fine. Lecture for grade 8, subject chemistry, chapter number 1, lecture number 7, and here is Mrs. Saira Jamal. Topic which we are going to discuss today is about Avogadro's number and mole. What is mole? Mole is a unit to measure amount of substances. What is mole? It is a unit used to measure amount of substances. Okay, same like as we are measuring mass in grams and kilograms, volume in centimeter cube and decimeter cube. So in chemistry, as substances are very small, very tiny, like they are atoms, molecules, and ions, and we cannot see them by naked eye. Even under electron microscope, we cannot see them. So special type of microscope called scanning tunneling microscope is used to see those tiny substances or tiny particles. So how can we measure those tiny particles? We are using a unit which is called mole. Okay, so what is mole? It is a unit used to measure amount of substances. And how we can abbreviate it? As kilogram we write kg, for gram we write g, for the volume we are using centimeter cube, cm cube. Same is for mole, we are using mol, mole. It is abbreviated as mol and we call it mole. Okay, now coming toward the definition, there are three definitions of mole, and the first one is a mole is an amount of substance that contain 6.022 into 10 raised to power 23 particles of that substance. One mole contain how many substances? One mole contains 6.022 into 10 raised to power 23 particles. These particles are too much. Okay, they are too much. Just imagine 602 and having how many zeros? 602 has 21 zero with it. So just imagine hexillions zeros are present and it is very large number. So one mole contain very large number of particles in it. Second definition, mole can also be defined as atomic mass, molecular mass. If it is an atom, so the mass is called atomic mass. If the substance is molecule, so we will call it molecular mass. And if the substance is an ionic compound which exists in the form of ion, so the mass is called formula mass. And if it is expressed in grams, not in AMU, the atomic mass, molecular mass, and formula mass, if it is in grams, not in atomic mass unit AMU, then it is also called mole. This is the second definition. The third definition of mole is the amount of matter that contains as many atoms, ions, or molecule as the number of atoms in exactly 12 grams of carbon 12 is called mole. Means carbon 12. What is the mass of this isotope of carbon? 12 grams. So 12 gram contain how many atoms, ions, or molecules? It is called mole. Okay. 12 gram contain how many particles? How many atoms? So those atoms are called mole. Okay. So same like the masses of all the atoms, we will say that their masses are equal to 1 mole. So what is mole? There are three definitions. First definition is a mole is an amount of substance that contain 6.022 into 10 raised to power 23 particles of that substance. Particles mean particle may be atoms, particles may be molecule, particle may be ions, particle may be formula units. That's why in second definition, you can see we explain it like this, that mole can also be defined as atomic mass, molecular mass, and formula mass expressed in grams. Third definition is the amount of matter that contains as many atoms, ions, or molecules, because particles I told you may be atoms, ions, or molecules, as the number of atoms in present in how much grams of carbon? 12 grams of carbon, which is the atomic mass of carbon. It is also called mole. Mole is abbreviated as MOL or mole, and it establish a link between mass and number of particles. As you can see, 12 gram has how many particles? It has Avogadro number of particles, or this 6.022 into 10 raised to power 23 particles, which are also called Avogadro's particle, because Avogadro's is the name of scientist, and he for the first time said that 1 mole of all the substances contain Avogadro's numbers of particles. So according to the name of that scientist, this unit which contain particles, those particles are called Avogadro's numbers of particle. So it is unit used to measure amount of substances. Amount of substances, I told you, that may be how many atoms are there. If it is an element, if it is a compound, how many molecules are there. If it is an ionic compound, and how many ions are there, or formula units are there. Mole, it is a counting unit, as I told you, and it is similar like a dozen. Dozen means 12. If we say a dozen of eggs, so dozen of eggs means it have 12 eggs. Okay. So if we say 1 mole of substance, it means it have 602 billion trillions of particles. Okay, you can see 602 and having 21 zeros with it. So in scientific notation, we can also write it 6.02 into 10 raised to power 23 in scientific notation. This number is known in is named in honor of the scientist Emilio Avogadro, and in 1776 is his date of birth, and 1856 date of death, who studied quantities of gases and discovered that no matter what the gas was, no matter what the gas was, any gas, there were the same number of molecules present in it. If 1 mole of hydrogen gas, 1 mole of nitrogen gas, oxygen gas, any gas, if it is 1 mole, it will contain these Avogadro's numbers of particles in it. Then relationship between mass and mole, as I told you that atomic mass, molecular mass, and formula mass expressed in gram is called mole. You can see if I have carbon, carbon is element, and the smallest particle of carbon are atoms, and so we will use the term atomic mass. Atomic mass of carbon is, you can see from periodic table, 12 gram, and it is equal to 1 mole of carbon. Molecular mass of water, because water is compound and compounds are made up of molecules, so we will use molecular mass of water, and you can see 16 plus 2 into 1 from periodic table is 18 grams, and again it is 1 mole of water. Formula mass of sulfuric acid, because sulfuric acid exists in ionic form, so expressed as 98 gram, and we will use 1 mole sulfuric acid. Sodium chloride ionic compound, we will use the term formula mass for it, and from periodic table 23 plus 35.5, 58.5 grams, it is equal to 1 mole of sodium chloride. So you can see the masses are different, but they are equal to 1 mole. Okay, whatever mass of atom of element, compound, or ionic compound is, whatever the mass is, but they are equal to 1 mole of substances. 1 mole of carbon, 1 mole of water, 1 mole of sulfuric acid, or 1 mole of sodium chloride. So this is the relationship between the moles and masses. Whatever mass is, they are equal to 1 mole of water. Okay. Avogadro's number, I told you, is a special number of particles which are present in atoms, molecules, or formula units. You can see in chemistry, we deal with substances, or we measure substances like atoms, molecules, or formula units, which are composed of atoms, molecules, or formula unit. The counting of these particles is not possible for the chemist, because 1 dot of a pen, if we put 1 dot of pen, it contains millions of atoms. So how can we measure those millions of atoms? That is not possible for the scientists to measure the million and trillions of atoms. So the concept of Avogadro's number helped them in counting particles contained in the given mass of substance. And Avogadro number is represented by capital N with a capital A as a subscript. Hence, this number is called Avogadro number, and this may be for atom, molecules, or formula units. And it is equal to 1 mole of substance, and you can see again 602 or 602 hexillion particles are present in 1 mole. Okay, 1 mole contain 602 hexillion particles in 1 mole. You can also take this example. If you had 6.02 into 10 raised to the power 23 watermelon seeds, okay, then it would be found inside a watermelon slightly larger than the moon. Means Avogadro number of particles if they are present in a watermelon. So the size of that watermelon must be same like the size of Earth. So just imagine how greater number is it that those seeds can be accommodated only in that much area or much watermelon which has a size equal to a moon. For counting a relationship between Avogadro's number and mole, what is the relationship between mole and Avogadro number? You can see from the formula, number of moles is equal to number of molecules over Avogadro's number. This is a very important formula because many numericals you will solve by using this formula. Okay, this is the relationship between moles and Avogadro's number. For counting atom, molecules, and ion in a substance, chemists use a unit called mole. I told you it is a measuring unit. Just as dozen of eggs mean it have 12 eggs, and ream of paper means 500 papers are present in one ream. Pair of shoes contain two shoes. Same 1 mole of substance contain Avogadro's number of particles. Okay. If we have 1 mole of carbon, carbon is element, so the numbers are same, but we will write atoms. Sulfur is element, we will write atom. Hydrogen H2 is molecule, so we will write Avogadro number of molecules. Water is compound and the smallest particle is molecule, so again molecule. But sodium chloride is ionic compound. Numbers are same, but at the end we will write formula units. Okay, these terms are, the particles are different, but 1 mole, 1 mole, 1 mole of any substance, if it is element, if it is molecule, if it is ionic compound, or it is formula unit, all have Avogadro number of particles, and particles are different. If element, then particle will be atom, element particle will be atom. If molecule, particle will be molecule. If compound, particle will be molecule. If ionic compound or formula unit, then particle will be formula units. I told you the mass of one mole of substance is called molar mass. 1 mole and its mass 12 gram. It is called molar mass. 1 mole sulfur 32 gram molar mass. 1 mole hydrogen 2.016 gram molar mass. Molar mass, molar mass. Mass of 1 mole of all substances. If they are element, if they are compound, if they are molecule, if they are formula units, their masses are called molar masses. All these are called molar masses. So 1 mole of all the substances, whatever their molar mass is, they always contain Avogadro's numbers of particles. I told you particles are different. They may be atoms, molecules, or formula units, but they are, if same mole, 1 mole, then they contain similar number of particles. And these moles are for one, you can see for one atom. Okay, 12 grams, 1 mole equal to 1 mole of carbon, and Avogadro number of particles are present in. Now gram atomic mass, gram formula mass, and gram molecular mass. Atomic mass of an element expressed in gram is called gram atomic mass. You can see atomic mass of carbon is 12 AMU. If we represent in AMU unit, then we will call it atomic mass. But if we, instead of AMU, if we represent it in grams, then it is called gram atomic mass. Atomic mass of sodium, if you see it from periodic table, it is 23 atomic mass unit. And if we represent it in gram, so it is called gram atomic mass. Atomic mass of zinc is 63.54 AMU, but if we represent it in 63.54 gram, it is called gram atomic mass of zinc. So atomic mass of an element expressed in gram is called gram atomic mass. Again, The smallest particle of element is atom, so we will use atomic mass. Okay. Now, atomic mass of a molecule expressed in gram. Molecule, I told you, hydrogen gas or any compound whose smallest particle will be molecule. Then atomic mass of a molecule expressed in gram is called gram molecular mass. You can see molecular mass of water. Water is a compound. So we will not use atomic mass for it. We will use the term molecular mass of water. AMU is 18 AMU. But if we represent it in gram, 18 gram, it is called gram molecular mass of water. Same molecular mass of glucose is 180.096 AMU, but if we represent it in grams, 180.096 gram, it is called gram molecular mass of glucose. Formula mass of a substance expressed in gram is called gram formula mass. Formula mass of ionic compound like sodium chloride and potassium chloride. If we represent it in AMU, 58.5 AMU and 74.5 AMU, it is called formula mass. But if we represent it in grams, 58.5 grams and 74.5 grams, then it is called gram formula mass. So atomic mass, molecular mass or formula mass expressed in gram is called mole. Combinedly, we call it mole, but separately, if we represent atomic mass in gram, it is called gram atomic mass. If we represent molecular mass in gram, so gram molecular mass. If we represent the formula mass in gram, so it is called gram formula mass. Size of mole, I told you the size of mole, it contain 6.022 into 10 raised to power 23 particles, and I told you they are hexillion particles, 602 hexillion particles, and it is not possible. Suppose if we have 1 mole of coins, 1 mole of coins if we have, so they say entire population of the world, they cannot count that 1 mole of coin in one air even, and they need about 1 million air to count them. So when counting a pile of coin, it will not be convenient to count them one by one, because this large number of coins cannot be counted. It is not possible to count them. So the easiest way is if we know the mass of one coin. Suppose mass of one coin is 12 grams. So we will just find out the total mass of all the coins which are present in that bag or in that pile. So weighing is an easy matter. 1 mole, and if it is 12 grams, so it's understood that it will contain Avogadro's numbers of particles in it, or 6.022 into 10 raised to power 23 particles in it. So an easy way is to weigh them instead of counting all the coins individually. So if you know the mass of one coin, you can count them by weight. How big is a mole? The volume occupied by 1 mole of soft balls will be about the size of the earth. You can see soft ball, if they are 1 mole. So how many balls will be there? There are Avogadro number of balls mean same like the size of the earth. So just imagine how big a number is this. Differences between the term gram atomic mass, gram molecular mass, and gram formula mass. There are three differences actually. The first one is from the name indicated gram atomic mass. Atomic mass means this is for 1 mole of atoms, and those 1 mole of atoms are present in element. So if we say gram molecular mass, so it represents molecules, and molecules are present in compound. Okay, and or an element that exists in molecular state, whereas gram formula mass represent 1 mole of an ionic compound. Gram atomic mass represent atom in element. Gram molecular mass represent molecules in compound or element in molecular state, like hydrogen. H2 is a molecule, but it is an element because it is made up of similar atoms. Okay, so I told you in the previous lecture that some element they exist in diatomic form, H2, N2, O2. So we will also use gram molecular mass for those compounds, for those elements as well, and formula mass we use for ionic compound. Second, gram atomic mass contain Avogadro number of atoms. Gram molecular mass contain Avogadro number of molecules, and gram formula mass contain Avogadro number of formula units. Only difference is in Avogadro number of atoms, Avogadro number of molecules, and Avogadro number of formula units. Okay, this is the difference. Gram atomic mass contain Avogadro number of atoms, atomic mass, so atoms. Gram molecular mass contain Avogadro's number of molecules. So molecular mass for molecules. Gram formula mass contain Avogadro number of formula units. So formula mass for formula units. Third difference is all of these quantities represent molar masses. Mass of 1 mole of a substance expressed in gram is called molar mass. Therefore, mole can be defined as atomic mass, molecular mass, or formula mass expressed in gram is called mole. Okay, very important question for short question answer, or sometime it comes as a part or B part in long question answer. Okay, so very important the three differences between gram atomic mass, gram formula mass, and gram molecular masses. Now coming towards mole mass calculation, here we have some numerical problems, and we will use different formulas to find out or to solve out these numerical problems. The first one is example 1.5, and mole mass calculation. In some numericals they will ask about moles by giving mass, and in some numerical they will ask about mass by giving moles. Okay, so you can see the first example 1.5, calculating mass of 1 mole of a substance. We have to find out mass, and moles are given. Moles given is 1 mole. Okay, 1 mole is given, and we have to find the mass of the substance. So 1 mole of all the substances, their masses we will find out from the periodic table. The first one is 1 mole of sodium. To find out the atomic mass of sodium, which is 23 grams. Okay, so 23 grams are the moles of sodium. Nitrogen occur as diatomic molecule. Nitrogen occur as in N2 form. So we will multiply the atomic mass of nitrogen 14 by 2. It will give us the answer 28 AMU, and as we have find out molar mass, so we will use 28 grams. Then the third one is for sugar C12H22O11. So 12 into 12, there are 12 atoms of carbon, and atomic mass of carbon is 12, plus 1 into 22. 1 is the atomic mass of hydrogen, and multiply by 22, plus 11 atoms, and 16 is the atomic mass of oxygen. By solving all these, we will get the answer 342 grams. So these are the masses of 1 mole of sodium, nitrogen, and sucrose. Self-assessment exercise 1.8, calculate the mass of 1 mole of copper, iodine, potassium, and oxygen. So we will use the same. Atomic mass of copper is 63.4 AMU, and if we represent it in grams, instead of AMU, if I will write grams, so this is the molar mass of copper. This is 63.54 gram. So this is for 1 mole. So 63.54 gram is the molar mass of copper. Iodine occur as diatomic molecule in I2 form. So we will multiply the atomic mass of iodine, which is 126.9, and multiply it by 2 will give 253.8 AM. So molar mass of iodine is 253.8 grams. Potassium exists in atomic form, or in monatomic form. So atomic mass of potassium is from periodic table 39 AMU, and if we represent it by gram, so 39 grams. Oxygen exists in diatomic form O2, so we will write 16 into 2 equal to 32 AMU, and molar mass of oxygen is 32 grams. Okay, so this is molar mass in grams. Example 1.5, calculating the mass of a given number of moles of a substance. Oxygen is converted to ozone. Ozone, you know, is the allotropic form of oxygen. Its formula is O3. During thunderstorm, ozone is prepared from oxygen molecule. Calculate the mass of ozone if 9.05 moles of ozone is formed. So ozone is a molecular substance, O3 is a molecule, and we have to find out its molar mass and use it to convert moles into gram. Moles into gram, because as they ask us to calculate the mass, they ask about the mass and they give us the moles. Okay, so 1 mole of ozone contains 16 into 3, 48 grams. Okay, so 1 mole of ozone is 48 grams. So 9.05 moles will be equal to how much? 48 multiplied 9.05. It will give us the answer 434.4 grams of ozone. Example 1.6, carbon dioxide is a molecular substance and determine its molar mass and use it to convert moles to mass. Again, they ask about when natural gas burns, carbon dioxide is formed. 0.25 moles are there. What mass? Again, we have to find out the mass. So 1 mole of carbon dioxide is equal to 44 grams. And the 0.25 will be equal to how much? 44 multiplied 0.25, so 11 gram of carbon dioxide. Next is example 1.7, converted grams to mole. Now this is different. In the previous case, they gave us moles and asked about masses. In this example, they gave us masses and asked about the moles. Okay, so molar mass of hydrogen is equal, because this is 5 gram hydrogen gas H2. So to find out the molar mass of hydrogen, we multiply atomic mass of hydrogen by 2. So 2.016 gram. 1 mole of hydrogen is equal to 2.016 gram. So if 2.016 is equal to 1 mole, then 1 gram will be equal to how much? 1 divided by 2.016, and this required one, which is the required amount, 5 grams. 5 gram will contain 1 over 2.016 multiply 5 moles of hydrogen. So it will give us the answer. Now B part, 1 mole of water. 1 mole of water mass is 2 into hydrogen 1.008 for oxygen 16, 2.016 plus 16, 18.016 gram is the molar mass of water. 1 mole of water is equal to 18.016. Okay, 1 mole 18.016. So 18.016 will be equal to how much? 1 mole, 1 gram equal to how much? 1 divided by 18.016. Then 100 gram of water, which is the required one, 1 over 18.016 into 100. Answer is 5.55 moles of water. These are just simple mathematical questions which you have done already. And this is self-assessment exercise 1.9. The molecular formula of bleaching hair, the compound which bleach hair is H2O2, which is also called hydrogen peroxide. There are two parts of this numerical. A part is here to find out mass, and B part is we have to find out the mole. Okay, so let's do the first part. Molecular formula of compound hydrogen peroxide is H2O2. Moles, given moles are 2.5 moles. Molar mass of hydrogen peroxide is 2 multiply 1 plus 2 multiply 16, 34 grams per mole, and you have to find out the mass of this compound. So mass of compound, we have formula, number of moles multiply molar mass. Okay, mass of compound, there are two methods. One method which I have done in the example. You can follow that method, or you can use this formula method. Both methods are correct. Okay, Whatever is easy for you, you can use that method. In this case, I'm using this formula method. So mass of compound has formula, number of moles multiply molar mass. Number of moles given are 2.5 moles, and for molar mass I just found it here, 34 grams per mole. After multiplication we will get 85 grams. So part A answer is 85 grams. In part B, grams are mentioned and they ask about the moles. So we will use another formula. Another formula is number of moles is equal to mass in gram over molar mass. Mass in grams are 30 gram. Molar mass, we just found it here. That was 34 gram. And 30 gram divided by 34 gram per mole will give me the answer 0.88 moles. So moles of this 30 gram of hydrogen peroxide are 0.88 mole. Again, I told you both methods are correct if you use the formula method or the BS method. Second part is a spoon of table salt. Sodium chloride contains 12.5 grams of this salt. Calculate the number of moles it contains. Sodium chloride is also called table salt, and they give us grams means mass and ask about the moles. Okay, so as mass is given and we have to find out moles, we will use this formula, the mole formula. Number of moles is equal to mass in gram over molar mass. So first of all, mass of sodium chloride given are 12.5 gram. Molar mass we have to find out. 23 plus chlorine is 35.5. By adding these two atomic masses, we will get the molecular mass or molar mass because we represent it in grams per mole. Number of moles we have to find out. So use the formula. Number of moles is equal to mass in grams over molar mass. 12.5 over 55.5. So 0.21 moles is the answer. Part 3. Before the digestive system X-rays, people are required to swallow suspension or barium sulfate before taking the X-ray. The doctor prescribed the patient to swallow suspension or syrup of barium sulfate. We have to find out the mass of 1 mole of barium sulfate. It means moles are given 1 mole and we have to find out the mass. So if moles are given and we have to find out the mass, then we will use this formula. Mass of compound is equal to number of moles multiply molar mass. Moles of barium sulfate given are 1 mole. Molar mass of barium sulfate. Barium is 137 from periodic table. Sulfur 32. 4 into 16 is atomic mass of oxygen. By solving it to 33 grams per mole is the answer. Mass of barium sulfate we have to find out. Formula of mass is mass of barium sulfate is equal to number of moles multiply molar mass. Moles are 1 mole. Molar mass is 2.33. Answer is 233 grams. Assignment or homework for today is do self-assessment exercises 1.8 to 1.9 and not 1.10 because we have not done it yet. So 1.8 and 1.9. Do these self-assessment exercises in your notebooks, okay? And do practice of all these numericals problem thoroughly. Inshallah, we'll do the rest of the numericals because there are different formulas for those numericals. All these examples and self-assessment exercises which we have done now, they have two formulas. One formula is mass one, which I told you this mass formula. If moles are given and ask about the mass, then we will use this formula. Mass of compound is equal to number of moles multiply molar mass. Okay. And second formula, if uh, masses are given and they ask about the moles, then we will use this formula. Number of moles is equal to mass in gram over molar mass. So all these examples and in all these self-assessment exercises, you have to use these two formulas. So learn these two formulas properly and then apply it on all these numerical. If you have any problem, then ask through WhatsApp group. Hope you understand the lecture. Thank you.